Let's go ahead and finish this up. We are on page 286, and we're going to talk about the graphing of the logarithmic functions. Remember when we talked in the pre-sections earlier, we said that the logarithmic function looks like this. Y is equal to natural log of x, or for that matter, any base x, right? Any base log, right, would look like this. We go 1. Okay. Now, if you want to look at this guy, so here we go, 1x, it goes like this, and it just goes up, and it goes all the way up. Okay. So that's the logarithmic function. So let's talk about describing how to transform these. So let's go A, so example number 5, we're doing example number 5 here. Example number 5. A, we have g of x is equal to log base 5 of x. Okay, so if we do that and we can go ahead and change the base here, it will be log x log 5. So if you call this y, right, you're going to do what? So you're going to move that over and you get y times log of 5 is equal to log of x, which is really 1 over log of 5. So it is a vertical shrink, 1 over log of 5, right? It's a vertical shrink. Okay, vertical shrink. Yeah, it's vertical shrink. Okay, so that's how you would do that one. It's a vertical shrink here, right? So B, on B, we have h of x is equal to log 1/4 of x. 1/4 of x. So it's the same thing, kind of, right? So it's going to be log of x over log of 1/4. Log of 1/4 is 4 to the negative 1. The negative 1 goes over like that. So you're going to have, again, if this you call this y, you're going to have log of 4 y log of x. Okay, so you have a negative here. Let's see where we're going to put the negative. So let's kind of not do this way. Let's go ahead and put it like this so it's not. Let's go ahead and put the negative over here. So again, we're going to do the 1 over log of 4 thing here. So we're going to start with y is equal to log of x. So we did a vertical shrink of this, but then where y was, I put minus y. So what that's going to be a reflection. And since y, wherever y was, I put negative y, that's going to be a reflection across the x-axis, correct? X-axis. Okay, so that's good. All right, we're good there? Okay, so let's go to the re-expressing data, okay? So if you look at page 287 in the middle, there's a table there. So there's actually 2 ways to do this, okay? So if you look at re-expressing data, so the one way that we're going to talk about here is that we're going to talk about, we're actually going to take the log of these data, and then we're going to go ahead and plot it, okay? So we can do that. So that's example number 7. Example number 7, it says re-express the A and T pairs on table 3.20, which is the one over here. And we're going to take we're going to take the natural log of A and natural log of T. Okay, so you're going to take the natural log of the distance and the natural log of the orbit. Okay, so then you're gonna actually plot log n, actual A, and then on the other one, you're gonna have T. And you're gonna replot this data, right? And if you do that and you do a linear regression, you will find that there is a linear regression, right? You'll find that there's a linear regression. You'll find that the y, you'll find that natural log of t, this guy is a y, right, is equal to 1.5 times the x plus 0.007, which is basically, so this is basically 0 here, right? This is 0, goes away. So you're going to end up with this. So you're going to get the natural log of t is equal to 3 over 2 natural log of a. That's what you're going to find. Well, if I multiply the 2 over here, I get this. So now I can go ahead and take the 3 and put it back over here. I can take this 2 and put it up here. So I can basically say that t squared is equal to a to the third. Okay, so this is the relationship you're going to find. In other words, since the t, this was the y, this was the original y, this was the x, you're going to find like that. Okay? So that would be how you would re-express it. So that would be the part, that would be the one way to do it. Okay, what's another way to do it? Another way to do it is actually you can go ahead and do a logarithmic regression. So if you go to stat edit and put in L1 and L2, you plot it, and before and then you can do a stat calc. And when you go to stat calc, it gives you all the different type of regressions you can use. So in here, we actually took the natural logs and then did the linear regression to find this equation. Okay, but instead of doing that, you can go ahead and just use a and t, and then do a linear regression. Logarithmic regression, and then you would find this. Okay, so the different ways you can do that. Just letting you know that there are 2 different ways, and that's it. And we'll let you go ahead and complete the homework then.